Good morning, class. Today we continue the chapter number 2, part 2, units and measurement, in which we discussed about the dimensional analysis. In dimensional analysis, today I'll discuss about the correction or check the correctness of the dimensional formula, whether the formula is correct or not. So start. Today we start with one question, that what do you mean by 7 dimensions of the world? In previous class we are discussed about 7 fundamental quantities, which we also called as base quantities. So let's start about the 7 dimensions of the world. All the derived physical quantities can be expressed in terms of some combination of the 7 fundamental or base quantities. We call these fundamental quantities as the 7 dimensions of the world, which are denoted with square bracket. What are these 7 fundamental or base quantities? These are length, mass, time, electric current, temperature, luminous intensity, amount of substance. So the dimensions of these 7 are: dimension of length is L, dimension of mass is M, dimension of time is T, dimension of electric current is A, dimension of thermodynamic temperature, or simply called temperature, is K, dimension of luminous intensity is CD, candela is the unit of luminous intensity, dimension of amount of substance is mole. So now we are going to start with the dimensional formula of few physical quantity, which we have already expressed in the earlier class. So let's start with the first one, frequency. In 9th standard we have discussed about that frequency is equals to 1 by time. Then this t goes in the numerator place, so it becomes t minus 1. So you can express the dimensional formula of frequency is t minus 1. What about the other dimensions? What about other 7 dimensions? So you can express that mass raised to power 0, L raised to power 0, and t minus 1. You can express the dimensional formula are in that form or expressed in this form. Is it clear? Now the next one, velocity or speed. Both are having the same dimensional formula. The general formula of velocity is displacement by time. Displacement measured in length? Yes. So speed is equals to distance or displacement, and displacement measured in length by time. Length by time. So L, t goes in numerator place, so it becomes t minus 1. So you can say that the dimensional formula of velocity or speed is L t minus 1, or you can express in term of mass raised to power 0 L T minus 1. Is it clear? Now, when we going to the further dimensional formula, we are using this dimensional formula directly to make the dimensional formula of others, like acceleration. The general formula of acceleration is change in velocity by time interval. See, change in velocity is still velocity. So you can say that velocity by time. So acceleration is equals to velocity by time. And in the previous formula, we are discussed about the dimensional formula of velocity. So put directly the dimensional formula of velocity here, which is Lt minus 1 by t. So this t is also goes in numerator place, so it becomes t minus 1. So t minus 1 L t minus 1 into t minus 1. So our formula becomes L t minus 2. Are you understand? Good. Now the dimensional formula of impulse. See, the general formula of impulse is force into time, and in the previous formula force we are taking directly the formula of force over there. The dimensional formula of force is mlt minus 2. So impulse is equals to force. Dimensional formula is ml t minus 2 into time, so t. So the new one is ml. See, when two quantities whose base are same, then powers are add minus 2 plus 1, so it becomes minus 1. So the new dimensional formula is ml t minus 1. Are you got it? Good. Now I'll explain you two dimensional formula more. First we discussed about the dimensional formula of surface tension. Now surface tension, the general formula of surface tension is force by length. In the previous slide we are discussed about the dimensional formula of force, which is mlt minus 2. So surface tension is equals to force ml t minus 2 by length L. So L to L cancelled. So the formula become surface tension is equals to m t minus 2, or you can express like m L0 t minus 2. You can express in both the forms, either this one or that one. Is it clear? Good. Now strain. This formula is new for each and every one who in a learned standard. We can understand about these physical quantities in further upcoming chapters. So strain, the general formula of strain is change in dimension by original dimension. See, dimension word. Dimension is what we have discussed. So strain is what? If we take a one dimension, let us suppose change change in length by original length. This del signature sign is for change. So change in length by original length. So the dimensional formula of length is again L by L cancelled. So you can say that the dimensional formula of strain is M0 L0 T0. That means it is dimensionless physical quantity. Okay, are you understand? Good. Now, application of dimensional analysis. There are few dimensional analysis, application of dimensional analysis are there. First, to understand that what is analysis, dimensional analysis. The method of studying a physical phenomena on the basis of dimensions is called dimensional analysis. Following are the three main uses of dimensional analysis: to convert a physical quantity from one system of units to other. This we discussed in the next class. Second is to check the correctness of a given physical relation that we discussed today. To derive a relationship between different physical quantities. First and third we are discussed in the next class. Okay. So let's start with the second one, to check the correctness of a given physical relation. Now, I'll give you one example. Check whether the following equation is dimensionally correct or not. So let's start. The formula is given over there is half mv square equals to mgh. Are you familiar with these two formulas? Yes, you are familiar with these two formulas in 9th standard. Half mv square is the dimensional formula of kinetic energy, and mgh is the formula for potential energy. So let's start with the solution. Now first we take the LHS part, half mv square. In the previous class we have discussed about that the dimensional less quantities. So this half is what? Dimensionless quantity. So we are simply ignoring it and putting the dimension of the physical quantities. Now first m. So the dimensional formula of mass is m. Second one is velocity square. We have discussed in the table given to you of the dimensional formula that velocity, the dimensional formula of velocity is Lt minus 1, and here the square of the v, velocity, so you can simply put whole square over there. So this is m Lt minus 1 whole square. This whole square is only for Lt minus 1. So mass is still as it is, and you know that when a physical quantity having two powers, then the multiplication of the two powers are, here the power of L is 1, 1 into 2, 2, and T, minus 1 into 2, minus 2. So the dimensional formula of half mv square is mL2 T minus 2. Now the dimensional formula of mgh. Dimensions of m is, mass is m. G is what? Acceleration due to gravity. So the formula is same as acceleration, which is Lt minus 2. And h is what? Height, and height is measured in term of length, so L. So now m, see there are 2L, So the power is add 1 plus 1, 2 and t minus 2 as it is. See these two formulas is same? Yes. So the dimensions of LHS is equals to dimensions of RHS. So you can simply say that the given equation is dimensionally correct. So that is the check whether the formula is correct or not. Now the second example. Check the correctness of the relation tau equals to I alpha. This symbol is for torque, which having a symbol of tau, where tau is the torque acting on a body, I is the moment of inertia, and alpha is angular acceleration. So again we are taking the solution. The equation is given over there, which is tau is equals to I alpha. Now the formula of torque. The general formula of torque is force into displacement or force into distance. We have discussed about the dimensional formula of force, which is mlt minus 2, and the dimensional formula of distance is L. So our new formula become ml2t minus 2. So that is the dimension of the LHS part, torque. Now RHS part. First we discussed about moment of inertia, only I. The general formula of moment of inertia I, which is mass into distance square. Now the dimensions of mass is m and distance is L. So distance square it becomes L2. Angular acceleration. Now angular acceleration is what? Angular acceleration is equals to angle by time square. Angle by time square. Now the general formula of angle is, our dimensional formula of angle is m0 L0 T0. That is the dimension of angle. So we are simply put 1 by time square. Time square is t square. So this t square goes in numerator place, it becomes t minus 2. Now the dimensional formula of I alpha. The dimensional formula of I is ml2 and alpha is t minus 2. So the LHS part and RHS part of the given equation is again the same. So the dimensions of LHS is equals to dimension of RHS. So you can say that given equation is dimensionally correct. Now third example. Check the dimensional consistency of the following equation, that whether the dimensional formula of the given equation is correct or not. I'll solve only the one, and the second one is your homework. Is it clear? Good. Now first one is de Broglie wavelength. The formula is lambda is equals to h by mv, where lambda is wavelength, h is Planck's constant, m is mass and v is velocity. So let's start with the LHS part. Wavelength. Wavelength having a dimension similar to length, because wavelength is a distance. So lambda is equals to L. The dimensions of lambda is equals to L. Now the RHS part, h by mv. H is Planck's constant, m is mass, v is velocity. So we can directly put the dimensional formulas from the given table. The dimensional formula of Planck's constant is mL2 t minus 1 upon the dimensions of mass is m and dimensions of velocity is lt minus 1. So t minus 1 to t minus 1 cancelled, L to 1L is cancelled, m to m is cancelled. So only which dimensions over there of the given formula is L. So again you can say that the dimensions of LHS is equals to dimension of RHS. So the equation is dimensionally consistent, or you can say that dimensionally correct. Now some more homework to you. Check the method of dimensions whether the following equations are correct or not. I'll given to you 4 equations over there. E is equals to mc square, where E is the energy, m is the mass and c is the speed of light. Second, T is equals to 2 pi square root L by G, where T is time, L is length and G is acceleration due to gravity. And 2 pi is what? Dimensionless quantity. Third one is V is equals to square root P by rho, where V is velocity of sound, P is pressure and rho is density of medium. And the fourth one is nu is equals to 1 by 2L square root T by M, where nu is equals to frequency of vibration, L is length of the string and T equals to tension in the string, and M is mass per unit length. See, this 2-dimensional formula is not available into the table, so I'll provide you this 2-dimensional formula over there, so watch carefully. T is a tension, and tension is similar equal to force. Tension is a kind of force, so you can put directly dimensional formula of tension as equal to dimensional formula of force, which is mlt minus 2. Okay, are you note down this? Good. Now the next one is mass per unit length. Mass per unit means 1, length is L. So the dimensional formula is ml minus 1. ml minus 1. Thank you class.